Some playing games first couple days here. Okay. Hey, first of all, I didn't realize you had never done a class challenge, so I was really impressed that you guys, for the most part, everybody participated. I could tell some of you were listening a little more, but you were engaged. Secondly, you were off to a really fast start, and it was tremendous. Like, this stuff is all correct. Okay, and by the way, you have satisfied the minimum requirement for the challenge. You'll get a little bonus. You missed kind of like the super deduper, though, and it was what you guys were getting at, the equation, but you kind of, you were kind of fading there, and you weren't sure if you were going to get an equation, but I like that you were thinking, wait a minute, there's an equation for this. So let's talk about that also. But multiplicity of 2 has a multiplicity of 2. What does that, how did you know? Where did that come from? 2 has a multiplicity of 2. Okay, so we'll give you credit that you said -2. So how come -2 is a multiplicity of 2? Because the graph just, right, it just bounces off, it just touches. And of course, that's the only touching we want to see. Now, you could have also said that 0 and 2 have a multiplicity of 1. That sometimes is a little more just like what you expect, but it is true. They have a multiplicity of 1. By the way, that's because they cross at those points. I'm going to give you credit for this because I know what you meant, but what's positive? Which end behavior?
The right side of the graph.
Good. So now, there still is something that's positive, which means that the right side of the graph has an end behavior that goes up. I feel like the degree is more of this statement. Does anybody know what you were meant when you said positive? Okay, it would be the leading coefficient. The leading coefficient. Now, part of the problem is we don't have a leading coefficient because we don't have an equation, right? But it's good, guys. It's good. You knew something was positive, and yes, the right side is going up. By the way, why is the left side also going up? Why is the left side also going up? That's because the degree is even, so it's going to be the same, right? It's going to be the same. By the way, what is the even degree? What is the even degree? I'm not sure if I heard somebody say it, but I know it wasn't written. 4. Got 4 roots. Now, is there a lot of stuff that's kind of like circling around in your head here? Do you realize how all this stuff goes together? Well, it does. Okay, the degree is even. Both sides are the same. The leading coefficient is positive, so the right side goes up, but it's even degrees, so the other side's the same. We got our roots. It's time to write an equation. Now, when you write your equation, and I wasn't sure how far you guys got on this, you would have to, and this is going to be today's lesson, but you would have to think about some factors. You would have to think about some factors. The factors just match the roots. And so, like I said, this is going to be today's lesson, but are you already ready to do this? -2 would be the root for x plus 2. -2 would be the root for x plus 2. X minus 2 would be the root for 2. And there's just one more thing that I need here. I need just an x. That's going to be for 0. And what we'll talk about is how you could, although I don't know if I expected that you guys, this would have been super duper, but that you can like multiply this stuff together. If you multiply it together, then you're going through what everybody considers to be like the FOIL method or whatever you want to call it, but you would have to distribute, combine, multiply, and you would end up with your polynomial. Okay, I'm going to stop short of doing that for this problem, but we'll do it for a couple examples. You would multiply it all out. Okay, before we maybe officially get into that, let me make comment, even though you were supposed to have already uploaded it, we didn't really get to talk about it. And how'd it go? How'd you guys do with what you were to try to learn yesterday? Nice job doing the homework. I did see a lot of right answers, but sometimes like number 6, number 8, sometimes they require a little bit of conversation. Do you guys want to talk about the British method for that? Okay, I kind of almost expect that you do. By the way, what I'm showing up on the screen there is more of just a little guess and check method for number 6. And just to speak of the guess and check method, 2x squared comes from 2x and x. That's kind of like you have to do that. And then -3, what numbers multiply to be -3? Well, 3 and -1, but you have to like figure out what order they go in. And the reason I know they go in that order is because I checked what happens if 2x multiplies to the number out here. By the way, that's -2x. And if 3 multiplies to the number right here, by the way, that's 3x. And -2x and 3x will add to the number in the middle. That's a little guess and check method. If you want to use like a British method, it's a little bit more of like a technique that, first you multiply these, and then you bring down, you always bring down the outside terms. So right now what I did is kind of like always. You always do that. And then here's the part that you have to do a little thinking. A little thinking is how you have to split up -6x squared. Now, do you remember how to split it up? You have to split into two numbers that multiply to be -6, x squared, but add to be 1x. So your brain should say, wait a minute, that's going to have to be a -2x and a +3x. Now, again, the numbers I just wrote down multiply to be this number, add to be this number. And then you use a grouping method. Of course, if you did this correctly, your grouping method will lead you or leave you with the same factor. And that's usually when you say success, because you'll take that same factor and you'll write it down, and then you'll take these guys, which are also factors, and you'll write that down. Of course, you get the same thing I have up there. That's the little British method. Listen, we opened up a little can of worms. We just started a chapter on polynomials, so you kind of have to be thinking this way. Thinking this way means trying to remember some things from years gone by, but sometimes the teacher needs to review it with you. Are we okay with getting this imaginary answer? Is there anything else you want to talk about with the homework? Okay, sometimes the teacher says, I don't know how to take your silence. I don't know if that means you're good or you're just not sure what to ask. Go ahead. The factoring, or just kind of like the answer? So once I get to my factors, you're sure you're okay with factors? I set each of those equal to 0. So this one's easy to set equal to 0. You just basically say x minus 6 equals 0. So geez, x equals 6. This one, okay, until we get kind of comfortable with it, maybe off to the side, you set it equal to 0. And then you solve it. Again, until you get comfortable with this, show this work. Now I'm going to take the square root of a negative number. There's a couple things going on there. When I take the square root, I always get plus or minus. If it's a negative number, it's going to produce an imaginary result. So again, the square root gives me plus or minus. The negative on the inside gives me the letter I. The only thing left to do is to say, okay, what's the square root of 4? Well, that's always been equal to 2. That's how I get all 3 parts to that answer. Okay, now the stuff that we're going to keep doing today relates back to yesterday. The stuff we do tomorrow it all like interrelates. So it doesn't mean that we're moving on to something else. We're just going to continue to build onto this. What we're going to do today is what you guys almost did on your little challenge, which is we're going to try to write some polys. You're going to find out real quickly that this just takes what you did yesterday and applies it backwards. Now, the main application is this, and it's what I kind of started doing in that first problem. the main application is to take a root. Remember, a root is an answer, and just to write it as x minus that root. In other words, to write the factor. If you're looking at that and saying, what does that mean? We'll do it. I think you'll find out quickly that it always means the same thing, but it's the main method to create a factor. Now, sometimes kids will say, is it always minus? You have to understand that the minus symbol is really referring to an opposite sign. So could I have a plus sign in there? Yes, if my root was already minus. Okay, but again, the factor is always going to be like the opposite. Let me show you the type of problem we're going to do. Again, I think you'll hopefully catch quickly that it'll end up being the same idea every time. So I'm going to give you some roots. You're going to write the equation. That's the kind of problem we're going to do. I'm going to give you some roots. You're going to write the equation. Now, you don't have to wonder if there's something else going on. If the problem didn't give you more information, all you do is take what I gave you. So I gave you x equals 4. Oh, x equals 4 again, and then 0. So you don't have to wonder if there's something else that you have to assume. Just take what I gave you. And the good news is you can take what I gave you and just start writing the factors. So I hope you would write x minus 4. But as you realize from yesterday's lesson and today's little challenge, I can have it again. And then be careful that you don't make anything else out of 0 than just the letter x. Okay, now, typically, or actually all the time, we want our equation in standard form. Standard form just means that you have to multiply it out. So whether you like it or really like it, you got to FOIL and expand. You know, you can FOIL and expand anything you want. The reason I put those together is because they're kind of similar, and it's maybe a little easier to say, okay, x minus 4 is going to be x squared. Now you get minus 4x and minus 4x twice, so that's going to be minus 8x. And if you're comfortable, just skip right on to it. And then, of course, minus 4 and minus 4 is going to give you 16. And then everything can just get pumped up by one more x. And you've got yourself your polynomial. Now, are you ready for some sort of extra fun to add to this answer? Most of the time, there's a graph that is kind of lurking in the background that we want to know about. Even though it doesn't say it up here in the directions, could you draw the graph? Well, we'd like you to say, sure, I can draw the graph, because I already knew that x equals 4 was a very important point. X equals 0 is a very important point. And a little bit of what you guys were talking about in the class challenge, the leading coefficient is positive. Now remember, if the leading coefficient is positive, you know the graph is going to go up to the right. And as you can see, I like to sometimes just draw that little segment. The degree is odd. The degree is odd. That means that the that the left side is going to be opposite. So I can draw it going down. And you've been around these a little bit, but of course we're reviewing them now. So do you remember how the rest of this goes? It has to touch and cross. It's the only way that you're going to be able to connect these dots. And just like that, you're able to draw P of X. The degree is odd. That means that Yes, now that's a good question. And let me just share, by the definition of degree, that is the first one, or really we say the highest one. So again, it's a good question for everybody. The degree is always the highest exponent. Should it be the first one? It should be the first one. If it's not the first one, it's not in order. You would have to reorder it.
And what does that mean?
It means that the behavior, after we said it was opposite, I drew the left side behavior.
Oh, so it's the opposite.
Yeah, I kind of said that wrong. If it's odd, then I drew the left side behavior the opposite. And that's what it means. So what do we got here? -3, 5. Uh-oh, 2i. I hate those imaginary numbers. No, don't hate them. They're a little weird, but they're, as I hope you realized from yesterday, they can be roots. Imaginary numbers can actually make something equal 0. Now, I'll say purposely there's a little typo up on the screen so that I can say this to you. Imaginary numbers always come in, did you hear it yesterday? Imaginary numbers always come in pairs. That means if 2i is walking down the street, it has to be walking down the street with -2i. So basically, technically, if 2i is on the list, so is -2i. Again, I left that out just so we could have that quick conversation. Now, I can still, and I hope that with good confidence, I write down x plus. Are you tracking with me? X plus 3, x minus 5. I would imagine that you're fine with that. It's those imaginary numbers that we got to be a little careful. Now, again, I'm doing some of this on purpose. It's a review from yesterday because there was a lot of information yesterday. But anytime you have an imaginary number, it's always going to be x squared. It's always going to be plus. I hope that you remember hearing that, but if for some reason you didn't, imaginary numbers are always x squared and plus. The question becomes plus what? You have to think a little backwards. Now, if you were listening, we went over a problem on the homework that somebody asked about, but the number that I put right here, it's not going to be the number 2. It's going to be the number where that 2 came from. And of course, that's a 4.
So if you're an imaginary number, can you always square the number? Yeah.
Sort of the number it came from. In fact, yes. I don't like giving little shortcuts, but that is exactly what you always do. You just square that and you say 4. I assume you're just squaring the 2. You're not really squaring the 2i. Okay. Foil time. Now look, I know you guys have multiplied plenty of binomials together, but you have to be careful. X squared minus 5 plus 3 is going to give you minus 2x and then minus 15. So again, be careful. And then I got this x squared plus 4 that has to get itself in here. We have to do some distributive property. Okay, and you know, students organize this differently. Some students will just kind of like do what I did here, a little like hand coming out. So x squared times each one of these. Well, everything just gets pumped up by x squared. So now I have x to the 4th. Now I have x to the 3rd. Of course, minus 15x squared. And then plus 4, everything's just going to get multiplied by 4. If you've never organized your math like this, it's just something I saw a student doing once where they kind of organize the like terms. That is the 4x squared. They organize it underneath the negative 15x squared. If the problem is even more complicated, that would make it a little easier just to kind of put it all together. All right, so we get x to the fourth minus 2x cubed. Now we get a minus 11x squared minus 8x minus 60. Okay, kind of a big old polynomial. Again, welcome back to polynomials. And it's always a graph. Okay, now I hope the graph doesn't become kind of like, do we have to graph it? It's actually should be pretty easy to graph it. You've got all the information. Actually, the roots that we had back in the beginning are like some of the main piece of information. So we put the roots on there. Don't put the imaginary roots on. This is a real graph. Okay, so it's kind of weird, but the imaginary roots have nothing to do with this answer. The only thing left to do is think about the leading coefficient. Looks like it's positive again. So the graph goes up to the right. Looks like the degree is even. As you guys were talking in the little challenge, that means it's going to be the same on the left. Well, and if you were listening to my lesson yesterday, you say, well, there was kind of a problem like this yesterday, where basically the graph just looked like not a parabola, but basically just kind of a U shape. By the way, how far down does this thing go? In other words, what's the y-intercept? It's just a little extra check. It was something I threw in one of the examples yesterday, negative 60. And that looks good. If that was positive 60, then we'd have a problem. Oh, I even had that little x squared statement in a cute little cloud. Whoop. I want to kind of end where we started. This time, though, instead of it being a class challenge, just use the blank side of this, kids. Use the blank side. The other side of this paper is some recycled math. So, what do you think after just about 30 minutes of thinking about polynomials? Can you kind of satisfy the challenge? Let's make it an exit ticket.